So, towards the end of our conference, everybody's getting tired, and we have a talk about when MyRocks is good. So MyRocks is a storage engine. We'll talk about that, and then we'll get into that. And we'll repeat for some of you. My name is Alkin. I work at Percona in managed services. I'm a senior technical manager, and I do a lot of sailing. The rest of the stuff is work and boring. And here's my friend and colleague, Sergey. You want to introduce yourself?
My name is Sergei Kuzьmичев. I also work at Percona as a support engineer, and I worked with databases to some capacity my whole career, and I decided to go with that and join Percona. So I worked as a DevOps, as an Oracle DBA, with a lot of stuff. But, well.
Okay, so one thing good about Sergey being here, he can take Russian questions at the end. Okay, so today's agenda for MyRocks is we're going to go over intro and basics, very high level, what it is and what it does. And then talk about some of the advanced internals, the dynamics of the engine, how it works, and what does it do. We have some benchmarks and performance numbers that came out recently. And then we will close with tuning suggestions and the conclusion about the storage engine. So I will leave this part to Mr. Sergey.
So before talking about what is MyRocks, I actually want to ask, does any one of you use MyRocks? Or at least heard about MyRocks? So at least 2 people, 3, 4 people heard about MyRocks. That's great. So MyRocks, as Alkin told us, is a storage engine for MySQL. It is based on RocksDB, which itself is a fork of LevelDB, and RocksDB is a persistent key value store. It was made by Facebook, and MyRocks is also made by Facebook. And it was introduced around 2016, and they use it in production. They use it for their main graph, social graph database, and they recently migrated the Messenger database to it. As usual with such things, it was available as source code, but right now you can get it easily with major, MySQL flavors, with Percona server, with MariaDB. MyRocks is getting more mature. It's not really widely used. Nobody uses it here, and not a lot of people use it actually. So, what is MyRocks actually? So MyRocks is based on LSM3. And I will talk a little bit about it, but it's actually pretty complex. It is more optimized for writes, as we will show. It is really space efficient. It has some other perks. It also has downsides. And few of those are that it has no foreign key support, no serializable transaction isolation support, and no full text, no special keys. So LSM versus B3. Well, it's not really a fair comparison, but everyone knows what is a B3. So here it's actually B plus 3. And there you have basic overview of what is LSM and how it works. I will not go into much detail, and Alkin will go into detail on how MyRocks works specifically, but if you want to learn about the LSM itself, you should read this blog post or look it up somehow. But mainly, the main difference is the main takeaways about LSM that you always write to memory. You write sequentially to the special structures called memory tables. They are sorted somehow, and they get flushed to disk as sorted string tables that are immutable. You do not update them. You just write to them, and you just write to memory, flush to SSTs. Then there is a process that takes SSTs and kind of progresses them level to level, while removing duplicate rows. The important thing with LSM, it is log structured. It is log structured merge tree. And you do not update rows in place in that structure. You just write, you can have insert really down on the level 6, for example. Again, we will talk about that a bit. And then you can have a lot of updates. Each of them will be a record somewhere in SSTs. So just important takeaways there. Why is that important for databases? So B3, you update a row, you update it in place. You do rebalancing online, and every read will have access to all leaves immediately. So reader can expect that it can go and read anything. With LSM, you only write sequentially to memory, And there is the background processes that move those writes below to the file system and then progress them through file system. That has impact on reads, because the reads will have to read from the disk, from a lot of files on disk, from memory. That can be important and critical, and we will talk about that a bit. So you cannot talk about storage engines in MySQL and not talk about InnoDB and not compare with that. So we'll do that as well. So MyRocks will generally have better writes. Again, it's when you say that something is better, everyone will come to you and say it's better, and only in some cases, yes, right. But in general, due to how LSM works, you will have better writes. It sees less size. It is 2 times less than compressed InnoDB. It's 5 times less size than uncompressed InnoDB. Of course, InnoDB supports foreign keys, realizable, everything like that. And there is a significant difference in how they handle locking, actually. We will talk about that a bit. So MyRocks cannot be used in advanced replication. So everything we know, Percona XtraDB cluster, Galera, they are related, group replication, those only work with InnoDB. It's written right there in the documentation. And InnoDB supports statement and mixed binlog format, while MyRocks only supports row. And there is a caveat to MyRocks that if you are going to write a lot of stuff into it, you kind of have to think about the memory constraints, but there are ways to optimize that. So why would you try using that engine? Why would you consider that? If you have a data set that is much larger than memory that you have, right? So probably 100 gigabytes is not so large right now. You have to think about that. If you have multiple indexes, because the more indexes you add, the slower will be writes generally when you write to InnoDB. And of course, if you have write-intensive load, LSM3 is excellent for writes. You write to memory, you flush in the background. And pretty complex queries can be done in MyRocks, and they will work, but perhaps InnoDB will be quite faster there. And of course, if you have a lot of business logic and foreign keys and realizable transactional isolations are key points for you, you will not be able to use MyRocks. There is a nice chart made by Vadim Tkachenko, and you can check it out and check his webinar. And you kind of can see that InnoDB loses in performance the more data it has. So MyRocks is pretty stable there. There is a point, probably, when you will see that MyRocks is quite more performant than InnoDB, and that will be when the data size will get huge. Facebook used MyRocks and introduced MyRocks to save on costs. They had significant issue in that their database was huge, and they wanted to use their machines more efficiently, but they were constrained by the size of the data. And when using MyRocks, they could fit more databases on the same machines. And that is important for you. You are not Facebook, but you maybe use cloud. And in cloud, you pay for the disk, you pay for everything. So if you can use resources more efficiently, you can probably, well, you will pay less. And Percona did some assessment on different MySQL flavors and on the RDS, for example. And MyRocks actually comes pretty well. How to tinker with it? With Percona, it's quite easy. You can just use Percona release. You install Percona server. You install Percona server RocksDB plugin. Just enable it. See that engines are enabled. You don't need any downtime. You can create tables and tinker with it. You should check variables. I'm using 5.7. 8 has much better defaults, actually. And there is important thing that some variables, some configuration options are actually configurable per column family. It's quite advanced. Alkin will talk about that. There are some differences between distributions. They are not significant, but you should know about those. Okay, so advanced stuff, it's to you.
Okay. So thank you for the intro and the overview. As you can see, MyRocks actually is different than InnoDB that we mostly generally familiar with, and also the way that it works is slightly different. We're going to go into what the components are, Mem Table, log, and the structure, compaction, column families that actually makes the MyRocks engine. Again, just repeating, it was inherited from LevelDB, it's adopted by Facebook, and it's in production used by Facebook mostly. And also there are some other early adopters from older engines like TokuDB, and so we'll go over that. So the architecture looks like this. For we talked about writes, and then so it has uses an active mem table, and the mem tables gets actually switched when they're filled up, and then flushed to the SSD files. While writing the mem tables, it also keeps the write-ahead log as a pointer, and then they also get switched, and then creates the SSD files. And during that, the compaction happens. If we look at how does it handle the write, so for example, if there's an insert coming in, it actually writes into the wall, and mem table, it sorts and it creates a new SSD file that goes into the new SSD file. If it's an existing, well, it's an LSM, so it actually merges and compacts, then keeps adding to the new files by levels. So this is a representation of the engine structure in general. These are the main components. Of course, there's other stuff that happens around the compaction, switching, and actually handling the write-heavy workload. So we go back to over here. We talked about the mem table. So if we actually have a look at what's the mem table, it's limited to 64 megabytes, so it's not super large, but it's a memory table, and it gets switched, and you get actually create more and more of it. As Sergey mentioned, if you actually have a lot of writes, then you have to actually plan ahead for the mem tables, and how do you actually handle that kind of a workload you're writing. And every changes go to the write-ahead log, and actually keeps track of it, and we'll see that on the next slide. And then there's also a component to the column families. So column families are something that to think about how it works with indexes and the table structures. So the other component over here is the write-ahead log. So it's actually similar to the redo log in InnoDB. It acts like a pointer. It's never used unless you need a crash recovery. So it's a pointer for your writes, and basically the write goes to the memory based. So and then it SSD files gets flushed to the persistent storage. In the meantime, the pointers are kept in the write-ahead log. This is an illustration of a leveled compaction, and the leveled compaction is basically designed for writes that are coming in. Each level is configurable for these compaction that you make. We mentioned it's the LSM and the MyRocks is designed for large data sets. So this actually explains how you can actually achieve leveled compaction using the LSM while writing to your database. So I'm going a little fast because there's a lot of stuff to cover over here. And the compaction it happens on the row level, and then basically aligned with the operating system, 4 kilobyte units, and very little overhead for that. We are going to talk about the compression or compaction in the default algorithm is LZ4, and then if you look at the levels over here, every level is compressed. So it's not only like you have a level 1 up to 1 GB compacted, you also have the other levels compacted, and then you can configure by column family. And so the column family is actually helps us to manage the compaction. And so the compression results, so we did, Vadim also did some tests around what we should be using in Percona server for MyRocks compaction. There's other libraries available. You don't actually have to use LZ4, but there's from the tests that he came up with, the traditional zlib were actually pretty slow, and it did compress slightly better than LZ4, but overall the best speed and speed ratio balance-wise, LZ4 was chosen. That doesn't stop you to choose other compression algorithm. Actually, you can configure and use other ones if you feel like it. And based on the distribution, based on your operating system and a kernel, it may vary by the CPU power. So it's something as a reference. You could test it out and benchmark it and decide what to use for. Going back to the column families. So column families actually helps atomicity between the different key spaces. What that means is so we have the Mem tables and SST files, and it actually helps the shared transaction logs to be performed. And for each index mapping is 1-to-n relation that has, and then MyRocks has a configuration parameter for column family. I will show you how it's configured, and I think we have an example for that. And then for each index, you can actually create a command for column family for tracing back to what it's used in the database internals for checking the results. So we have some comparison between LSM on disk and LSM on flash. So InnoDB has write amplification, and basically you would actually write a lot of IOPS on disk, and LSM actually is a higher read penalty, but its reads are still good. We think it's write heavy workload, but it's actually also space saving for the disks. On the flash, it gets a little important because flash is more expensive, and then you get better compression off of the flash and on the disks. And then again, this is a illustration of architecture again, but this is for the read request. So how do we read? We have the block cache, which we will talk about on the internals of some of the variables that we have, and then the block cache. It's if there's a read request comes in, it looks at the memory as a block cache. It's like similar to buffer pool, and then it checks the indexes, and then use the Bloom filters, and then it actually points to the Mem tables if it's in the memory or not. And the Bloom filters allow to filter whether it's in that right set or not, and then it actually brings the data back to the request. And if it's not none of those in block cache or the Mem tables, it'll look for the persistent storage and SSD files to retrieve the data. And wall tables aren't used, it's just a reference for here from the architecture. Okay. So data structure and the query optimizer is slightly different versus InnoDB or traditional engines. So it has a primary key clustered, which InnoDB has that, and you would create a primary key for your tables as a best practice. If you don't, what happens? It does create one cluster primary key for you as a row ID, and the foreign keys aren't supported. There are no table spaces concept, but there are column families. So there's that. Online DDL not supported. I will show you some examples of the tooling how you can do online DDL. It's a little not same as the InnoDB as we could do. There is a lot of support in MySQL 8 for online DDL, and you can add indexes and stuff, but this is not possible. And so the optimizer statistics, actually it does keep optimizer statistics as an engine, and it has table statistics and index estimates, and you could actually query that with show engine RocksDB, and then it also supports the binary collations as Latin, and it's case sensitive, so this is important. Okay, so again, this is something similar. The optimizer statistics are kept as on the SST files, and they are calculated during the flush and compaction level. So they're slightly faster, and it's robust. And you still have the query optimizer and that kind of data. You can query that also from the data dictionary. So you have information schema allows you to actually look in the column families, index IDs, and the optimizer statistics. So we mentioned earlier the locking is different in the RocksDB engine and the InnoDB engine. So in the row level locking, you have read committed and repeatable read. So if you actually install MySQL, it comes as default repeatable read. But repeatable read is problematic in RocksDB because it doesn't support gap lock. If you did install the Percona server, it'll detect an error out saying that you have a gap locks, and so that's something to be careful about on your how do you actually handle isolation levels, and because of this, there's other relations to online DDLs and management and tooling of RocksDB engine. So it actually requires to have a row level bin log format, and it will create large bin logs, and it will not allow, because of that, it won't allow triggers on slaves, and it can actually have schema incompatibility between the slaves. And so if you did actually have a statement-based replication, then it issues the gap locks, and again, gap locks are not supported with the repeatable read of RocksDB. So there is a two-sided problem over there, which could be subsidized by setting some variables in RocksDB. Facebook has extended information about the gap locks and isolation levels. So they actually came up with some workarounds from both sides, from the engine side and the application side, to manage that. And then they detect inconsistencies and then report those, and try to handle it within the engine that actually supports. So how do we back up and recover RocksDB engine? Now we have InnoDB engine and then the RocksDB engine, but we are Percona's extra backup tool actually supports MyRocks backup, and it's optimized for InnoDB and MyRocks. For the MyRocks portion, you can't do partial backups, but it is possible to use extra backup to do backup. Although it's not recommended to mix engines, you can still do that and have a backup of extra backup to back up your MyRocks engine. On the MariaDB side, there is a Maria backup, also supports since 10.2, and it allows you to back up MyRocks engine. But there's no partial backups for MyRocks in Maria backup either. So backup and recovery, these are the distributions of MyRocks backup and recovery solutions, but also the Facebook and the original project, and there's a MyRocks hot backup that was created to backup at the time that no other tool actually was available for them, because there were no Percona or MariaDB distribution. So basically, they have come up with this tool to be able to do hot backups. This tool also supports a rolling checkpoint to be able to have a faster recovery time. Okay, so how are we doing with time? Okay. MySQL Dump. MySQL Dump can actually back up, and on the Percona server, MySQL Dump is optimized to detect MyRocks engine automatically. It is also possible to do snapshots, but you also have to do like a checkpoint MyRocks function to do a flushing and checkpointing, and then capturing the WAL file pointers, so you can actually have a snapshot and then recover a replication from that. How do we do a crash recovery if it's crashed? So if the immutable files are corrupted, they're not recoverable. You have to restore from a backup, and then there's recovery options. The one is default for the recovery mode. If the engine crashed, and it will fail to start, and then you need to actually figure out what to do and decide. If you choose other recovery modes, you might lose some data, and that depends on what you want to do. Okay, tooling. So in this list, I don't see anything other than Percona tools. So that means unless you write your own or rely on some of the Facebook open source tools, if there are any, But for monitoring, we use PMM, Percona Management and Monitoring Tool. We have special dashboards for MyRocks and MyRocks statistics. And then we have extra backup, which we mentioned. It's available since 8.06. Online schema change, same thing with the gap locking, and only it's available for read committed, so you can't do it on repeatable read, and it comes with repeatable read, and then you have a problem with that. So online schema change is partially supported. PT table checksum and PT table sync are not supported because they are not using row-based replication. They need to be on statement-based replication. So this is our tooling for handling MyRocks in general. Monitor with PMM, backup with extra backup. Online schema change is limited, and checksum and sync is not possible as much. What would they do if there's no checksum? And they would actually snapshot, clone another node and bring it up. So there's other workarounds for that. So the benchmarks. Okay, so benchmarks is something, this is very new. Our engineering department actually ran some tests on the most recent versions of Percona server. There will be more information coming about this. I just wanted to use this as a reference, how InnoDB and RocksDB engines performed under Sysbench TPCC test. This was about 100 and 120 gig data set that was run on 10 warehouses with 100 warehouses with 10 tables. So the results came out for the in-memory one. They were very close to InnoDB and RocksDB. For the writes, for the IO-bound load, the MyRocks actually performed much better after 64 threads or more. So there is another one over here which I wanted to share with you with 8 tables, 50 million rows on a Percona server 8.16. The IO in-memory was very close to each other, did not degrade much until 512 threads. But IO-bound workload, even though on InnoDB is super stable, which is very good, the MyRocks actually engine performed more transactions per second even after 64 threads per run. So these are the results that we have. We will be working more on this with other tests and other scenarios that I would like to share later on. Okay, good. So we have some tuning suggestions that I wanted to go over. Before we get to the tuning suggestions, how does the MyRocks engine work if I installed it from scratch? And today, some of you were in the previous talk, we had talked about installing MySQL MariaDB. What happens when you install, enable MyRocks engine in the first slides that we had while running that, it creates a .rocksdb directory under the default data there, which is normally varlib MySQL, and then puts everything underneath. All the SSD files, the log file, and the vol files actually go in there. Just one there. There's no one file per table option like we have it in InnoDB IBD files. And then there's a log file that creates for the RocksDB, but it's very high in verbosity. It's like a hard to read. It's a not human readable log file. I mean, it is, but it's too much data. It's writing right now. So that's how the data structure is built. The bulk loads are problematic. So if you actually have a lot of large data set to import into RocksDB during migration, you need to plan ahead. And there are some variables like bulk load, which manages the, after you load, you basically change these variables back to their normal values. It's something to test. It's not like for everyone. If you're constantly loading data, you may have to use different methods to how you split and load your data, but be careful. If the memory consumption is high, you may have some crashes if you load too much data that you can't handle with the memory and the IOPS. So there's something to not worry about, but pay attention to it during if you want to play around. so the block cache size is important. I think if 512 megabytes we said, is that
yes, by default
okay.
512.
So it comes with, so let's say we have a Percona server running and I enabled RocksDB engine. It'll have 512 megabytes of block cache, which is normally very small if we actually think about large data sets to load. So it's something to look, but there is also something that was implemented to simulate that cache size. You could play around with the simulation of that size and then see what's your hit ratio, and then come back over here and set that proper cache size by evaluating the number. So it's also, we recommended direct.io on bypassing the OS cache. You could set these variables to true. And the simulation of the cache helps to monitor your cache size, and then you can actually have hits and misses on the using show engine RocksDB status. That helps you to tune. So what other tuning suggestions we have is the background jobs. You could basically set your number of CPUs and cores, and the wall size is something tunable. To get a better compression, make sure that RocksDB block size equals to the 16K, which is a similar size of the page size. And so these are the variables that you might want to pay attention. It's not like always take these numbers and plug it in, it'll work perfectly. It depends on the workload. And we just want to highlight some of the tuning variables that we have in MyRocks engine for paying attention. And so there is memory limits, and then you have a couple of options, right? You have the Facebook MyRocks engine you can download and use it, plug it in, and then you can have Percona server, you can have MariaDB, MyRocks, and they all come with different defaults, and make sure that you check the defaults. And we have worked on MyRocks to basically implement in Percona server, and our engineering team actually had optimized some of the defaults already for the MyRocks engine variables. So okay. So in conclusion, for MyRocks, it's for big data sets. So if you have a large data set, it could be part of a different service. And if you have like a data set that is not living on your ExtraDB cluster, Galera, or group replication, and then you want to actually have a different data set on a large, you may not be on a Facebook scale, but you have a write intensive, you're ingesting a lot of data and want to write into that, and then actually have some reports out. RocksDB could be a good solution. Concurrent reads without range scans are very efficient, and because of the compaction and the library options that you have, it's efficient in the cloud. It'll be cheaper to run certain workloads instead of like so 2.5 in the size. If you have a terabytes of data, then that's actually a significant savings over a time. And if you're writing and reading immediately, that also you have a lot of benefits on the LSM tree structure. And that's all we have. I wanted to especially thank Yoshinori, who actually is Facebook's team lead, and Vadim is our CTO, and some other contributors, Sveta, and helped a lot for reviewing our talk. Mark is also has done an extensive research and development on RocksDB. The link has his blogs about his benchmarks and data. And I also want to thank all the engineering experts and services team at Percona who helped me and Sergey put together this talk. Thank you. Okay, now questions. Okay.
Thank you for your presentation. My question is, for which kind of data RockDB will be ineffective?
Do you want to answer that?
No
Okay.
problem. Say, for example, if you are going to read a lot of historical data, due to how RocksDB is organized, you can actually have a lot of penalty on the reads there. In how it works, you get a row, an update, for example, in the memory, it gets to level 0, goes level 1, level 6. The deeper it gets, the larger, the more the files you have. There is no specific data. It's more about the access pattern there, because if you write and read immediately, MyRocks will be great there. If you write a lot, hardly ever read, it will be fine. If you kind of write a lot and then at the same time you expect to read a lot of that immediately, but logic historically, that will not fit you greatly. I can't give you concrete examples, actually. We can talk about your specific case if you are trying to apply that for you, and we can try to understand if it will be all right. But it's, again, hardly data specific. It's more access pattern specific, okay? If that helps.
Thank you.
I think there is a question here.
She has a question.
Thank you. Maybe I missed. If we are using InnoDB in production and then we think that maybe we should consider to use MyRocks, how painful the migration would be?
Okay.
I mean, to migrate the data. I understand that if we use maybe some advanced features, I don't know, SQL or someone else, then it could be painful enough.
So I think the default Percona answer will be it depends, but I'll give you one example for that. If you have already in production and you have a large data set, migrating a large data set into RocksDB engine, you not only have to change your topology, but also have to change the behavior of the application. So over here, what we have seen from, or what we heard from Facebook, they adopted both. So it's not like you can actually change the engine to RocksDB and be good with it, because you have the gap blocks problem, you have the isolation level problem, you have the tooling problem. I mean, there is multiple parts to it, and then you have to take it in stages or phases to migrate into that. What we say when we ever do a migration, and for our customers, you have to test it, and then test it, and then test it, and then you will do it. That whether it's a cloud migration, or engine migration, or a server migration. So,
following question. I understand that we need to adjust the application and so on, but like if we had done all this job, is there an option to replicate the data, or some option to move the data from one from within InnoDB to MyRocks? I mean, built-in or made from Percona, something like that.
do you want to?
Yes, sure.
Okay.
Yes, actually Facebook went that way. They had a master and they had semi-synchronous replication to a lot of InnoDB slaves, and they switched one slave to RocksDB, and it was replicating from the master. Then they switched standbys, and they had 2 standbys in MyRocks. They actually promoted MyRocks to the primary and had InnoDB slaves in the meantime. So yes, it is doable. There are some caveats to that. We can talk about a bit more later, but you can do that. Yeah.
Yep. Thank you.
Thank you for your speech. Maybe I missed something, but as I understood that the first layer is Mem tables, and what about consistency? What if server will crash, and what will be with data? And the second question: could you provide any real use cases like storing user history, or some statistics, or sessions, or cache, something like that?
So for the, I'll take this. For the consistency, the data is already consistent, and if it's crashed, depending on your crash recovery, you will actually gain the consistency level that you actually choose. So by default, you have to make a decision whether you actually choose one of the recovery options or not. This is the same as other engines, right? DB, other engines. Your settings are are set to be consistent to begin with. And what was the other question?
Like real use cases of using MyRocks database engines, like.
Do you want to go?
Well,
Your Facebook example of
Yeah,
was
maybe
that
from the Facebook.
Messenger.
yeah, the Facebook, they basically migrated their graph, the social graph database, and then the Messenger database, which was huge, really huge. They migrated it first from MySQL actually to Hadoop for better performance, for cost savings. And when they were successful with MyRocks in their graph database, they kind of moved Messenger database back to the MySQL with MyRocks. You had questions like maybe history of some transactions. It could be good, okay, but you can write a lot, and there is also, I kind of skipped over that because we didn't have a lot of time, but when the compaction happens, and again, if you have more questions, we can talk about that a bit later, there is TTL for data. When the compaction happens transparently and actually for free, MyRocks can discard all data. You can set TTL for like a month, and in a month your data will be gone. So yeah, logging, history table, something that is doesn't have foreign keys, obviously, just you put the data there as quickly as possible and probably not read or read infrequently. Great scenario, but again, you can test it. And it's actually access pattern dependent.
Okay.
У кого-то есть еще вопросы?
You can ask. You can ask Russian questions also.
Yeah.
If anybody wants to do like.
Если вопросов нет, выберите лучший.
What do you think?
What's that? Sorry.
Okay, so I will translate. That was
I
like
need
a
a
question.
translation for that.
We should pick a question.
Oh, we should pick a question. Okay. I like that migration question. Okay. Thank you for asking the right questions.